New York City, symbol of America's power and in danger. A mosaic of islands in a bay along the Atlantic Ocean, the city is barely above sea level. Global warming has put the city at risk of devastating floods. By the end of the century, the sea level will have risen by 2 meters, and every 5 years, a cataclysmic hurricane could strike.
By the year 2080 or so, it will get very, very serious.
It's a recent threat. Up until now, New York has only experienced a powerful hurricane once a century. There was no reason for flood protection. The city grew at breakneck speed, building ever higher to become the quintessential skyscraper city.
There's no doubt that New York City is living with mistakes that were made in the past.
Since the end of the 20th century, the threat has accelerated. 1938, 1972, 2011 with Hurricane Irene. And then, just a year later, New York was struck with the worst natural disaster in its history.
When they tell you to evacuate, you need to evacuate.
In 2012, Hurricane Sandy slammed New York with violent winds reaching up to 150 kilometers an hour, bringing the city to a standstill and claiming dozens of lives.
That was the highest on the historical record since New York City was founded.
It definitely looked like an apocalyptic scene from, a movie.
Today, the danger is real. New Yorkers face a huge threat. 400,000 of them live in flood zones.
If the vast majority of the scientific community is anywhere close to right, then we have a problem we need to solve.
To save the city, engineers are dreaming up amazing technology, like a giant deployable wall that folds out around Manhattan.
It has to come up to 16.5 feet. If you do that, you know that it's going to protect any of the water from coming into the city.
An anti-flooding balloon has been designed for tunnels and even a waterproof building.
So we asked ourselves the question immediately after the hurricane, is it still safe to live here? The answer is, of course, yes.
Another amazing project, oyster beds implanted on seawalls to slow down powerful waves.
It's realistic, it's studied, it's very highly engineered as a project.
How did New York, in just a few centuries, grow into a megalopolis with extravagant architecture? How is the Big Apple preparing for the worst? Will New York be saved, or will it wind up underwater? This is the extraordinary adventure of a remarkable city that could soon be destroyed at the hand of what created it, water. New York was born 400 years ago. Located on the east coast of America, along the Atlantic Ocean, in a naturally protected harbor, the city is actually a bay strewn with islands. The most famous of them is Manhattan. At the time, it was 47 square kilometers. Back then, Manhattan was nothing like the current exuberant city it's now known as, the epitome of the American dream. A constantly buzzing, bustling city with 8.5 million inhabitants and hundreds of skyscrapers. In reality, this steel and concrete jungle has sprung up on what, not so long ago, was a real Garden of Eden.
I love to go to Times Square and there's all the lights and all the people and all the craziness, and to just try and imagine that there was a stream there and a pond and maybe a black bear walking by.
This is Manhattan today. And here's how it looked 4 centuries ago, covered in forest, interspersed with marshes and streams. A few hundred Native Americans were its only inhabitants, hunting and fishing to survive. But around 1620, Dutch settlers came to the wild island. They bought it for about $25. Despite the region's occasionally severe weather, the colonists settled on Lower Manhattan. One has to admit, the location is incredibly strategic. For starters, the harbor is extremely easy to access from the Atlantic Ocean. What's more, the 2 rivers, the Hudson to the west and the East River, offer gateways to countless commercial hubs in the eastern United States.
New York's growth is linked to the fact that its port was exceptionally located, a protected harbor that quickly made it one of the largest ports in North America.
Lower Manhattan urbanized quickly. The population tripled in a mere 20 years. And soon, the rest of the island was developed, but in a less orderly fashion.
The founders of the town realized there'd be no way to resist its fate. Immigrants were arriving, and the city was exploding, so to speak.
At the turn of the 19th century, New York shifted into gear to keep up with its ambitions. However, it didn't take into account the storms it suffered about once every 100 years. And as it developed, it left itself vulnerable to floods. The stroke of genius that allowed the city to build more buildings? Behold, the grid plan. It partitioned Manhattan into 12 avenues running north to south and 155 streets running east to west, dividing the city into blocks that could be built up in a way that made the most of space. The problem was that at the time, Manhattan was strewn with hundreds of hills and streams, a topography that was hardly compatible with building a big city. The answer? Clear the work surface. New Yorkers flattened some of the hills, channeled the rivers, and dried out the swamps, leaving room for streets, buildings, and before long, skyscrapers.
And in fact, it was criticized at the time. They said, what are you doing? You're planning a city that can hold the population of China, right? But they said, no, we need this grid. And so, the grid is the perfect Cartesian expression, right? Across the landscape. It didn't care where the streams were, it didn't care where the hills were, it didn't care anything about the marshlands or the coastal edge.
The only goal at the time was to welcome as many people as possible onto the land which is vulnerable because it's so close to sea level. With global warming, the shift in the island's topography is problematic because the entire flow of water has been modified.
The flows of rainwater to the sea or to the river will follow both above ground and below ground the topographies that had existed there before. So you get floods locally because of that pathway for rainwater. And some of it means that the underground streams are gorged with water when there's a major rainstorm.
Especially since New Yorkers can't count on their drainage system to absorb the overflow of rain. 150 years ago, the choice was made to develop a combined system that funneled both rainwater and sewage into the same pipes.
At that time, people designed these systems the best they knew. And there was nothing in the historic record that would indicate that they would have to build for such extreme events.
The upshot is that during storms, the sewers overflow.
So essentially, fecal matter is floating around in the Hudson and in the Atlantic, and they have to close the beaches because it's not healthy for a couple of days until Mother Nature flushes it out.
In fact, as it developed, New York made no allowance for the fact it sat on the waterfront and consequently could be flooded. Until now, the city hasn't really suffered, since in 400 years, there's only been one major storm per century. But 2012 was an irrevocable turning point. A massive hurricane struck New York.
When they tell you to evacuate, you need to evacuate.
October 29th, 2012. Hurricane Sandy struck the city full force. Gigantic waves surged through the streets of Manhattan.
So the storm surge that came in was large and wide. And also, it came at the same time as the high tide. And so we had a little bit more than 4 meters of storm surge coming into lower Manhattan, plus the waves, particularly on the ocean front. The waves would add to that.
That was the highest on the historical record since New York City was founded.
48 dead, entire neighborhoods destroyed, the subway at a standstill. New York panicked.
What's going on? I don't know what's going on. It's a hurricane. What the hell is this?
At 9:15 p.m., a power plant exploded, grinding the city to a halt.
The entire city went black, completely in the middle of the night. And you could still see the lights from Times Square, which is up on 42nd Street, but everything south of about 30th Street was completely black. And of course, nobody knew at that time how long the power was going to be out or what had happened. But the power ended up being out in most parts for almost a week.
New York City denied its existence on the water pretty much. And that was a reminder. Sandy really brought this home. We are a city on the ocean.
The entire city is in danger because New York is surrounded by 900 kilometers of coastline. What's more, it lies only 40 centimeters above sea level, and in some spots of Manhattan, not even 12. Geographically speaking, this makes the city extremely vulnerable to climate change. Today, the city faces two problems. First, the rising sea level.
The upper range for New York City is by the end of the century, by about 2100, that sea level rise could be 2 meters up here. And that makes a big difference when you have a city that has so much invested on its waterfront.
The second problem. In the future, hurricanes will be increasingly violent and will occur much more frequently.
That will be in the future occurring every few years instead of once in 100 years. We can have a Sandy once in 100 years or so, but if that Sandy elevation flooding happens every few years, that is, of course, unsustainable.
So how does New York plan to protect itself? What infrastructures could prevent this extraordinary city from disappearing under the sea?
It's a very tough moment, but I think it's time to start asking some of these harder questions.
Since the hurricane in 2012, the entire city has been preparing for battle.
You need stress or an event such as a hurricane to make sure that the city will be ready for the next time.
The City of New York launched an unprecedented design competition, investing nearly $1 billion.
It was a very simple functional question. How do we protect ourselves? And then it was a site-specific question. How can New York improve itself by protecting itself?
If the vast majority of the scientific community is anywhere close to right, then we have a problem we need to solve.
Architects and engineers from all over the world set to work to find solutions, what we call resilience.
I think of it like a boxer, right? You have two people fighting, somebody gets a big hit. Your ability to take the hit and not fall down is called resistance. It's how much you resist the disturbance. But if you do fall down, if you get knocked down, how fast do you get back up? That's resilience.
The first matter of urgency, protect Lower Manhattan. The zone was hit particularly hard by Sandy. Wall Street even had to shut down for 2 days, resulting in huge financial losses. That something like this should happen again is simply out of the question.
So it's simply the finances, the shutting down of the city, just the logistics of what it means for the heart of so much capital and so much banking and so much business would be shut down would have a huge impact on the world.
One of the brilliant ideas that won the competition is a U-shaped protective barrier stretching 12 kilometers around Lower Manhattan. It's called the Big U. The barrier is not a simple concrete wall. It takes on different forms to fit each neighborhood's needs.
If you're in the east side of Manhattan, there's much more open space. And you say, maybe in this case, a levee makes much more sense. It's cheaper. It works with the park next to it. And so you start to look at all the menu of different options. And so it changes. The entire length is a combination of the best selected pieces of flood protection.
In some spots, it will be an artificially created berm. There'll also be levees. In other areas, hills will be created to accentuate the topography and protect it.
The flood protection needs to come up to a certain elevation, right? So you know that in 2050, if there's a storm like Sandy, it has to be 16.5 feet above sea level. So even if it's a wall, if it's a gate, if it's a berm or a levee, it has to come up to 16.5 feet. If you do that, you know that it's going to protect any of the water from coming into the city.
The Big U's flagship project, a deployable wall to provide a barrier against waves. It will be attached here to the underside of the FDR, an elevated highway that runs along the East River.
So imagine above this is the FDR, right? Technically, this works in a very simple way. When the storm is coming, say 24 hours before, someone comes along and they turn these down. What they would do is they'd have a motor attached to the base, and it goes zzzz, and then slowly this thing comes down.
The wall, 3 meters high and 2 kilometers long, will swing down to block the water and prevent the waves from surging into the city. The rest of the time, the wall is flipped up so the ground space can be used recreationally.
The ground is where people want to be, and having a wall in the middle of that would destroy the relationship to the water and the use of the space on the ground. So by having something that could actually flip up, actually means that you keep the best part of the city while also making it fully functional.
The work is set to begin in 2019. Total cost of the project, $335 million. However, the barrier may not be enough. Because back when the city was being built, certain mistakes were made. Mistakes that New York pays a high price for in today's changing climate. By the mid-19th century, New York had exploded into a metropolis. With its extraordinary demographic growth, Manhattan was no longer enough. The neighboring districts began to develop: Brooklyn, Queens, the Bronx, and Staten Island. Since 1898, these 5 boroughs have formed the modern city of New York. They're connected by an extensive system of tunnels and bridges. One of the most well-known is the Brooklyn Bridge, which links Brooklyn to Manhattan. It was the first steel wire suspension bridge, and for years was the longest in the world, 1,830 meters. New York became the city of superlatives. Buildings kept going up and up. The Chrysler Building, the Empire State Building. Skyscrapers sprang from the ground like mushrooms, breaking records left and right.
In the late 1920s, a rather comical competition developed between the Chrysler Building and the Empire State Building, which ended up winning with its antenna that was taller than the one its opponent unexpectedly surprised the city with.
Today, New York boasts the most skyscrapers in the world after Hong Kong. But these towering giants have a direct impact on floods. Like in 1938, when a hurricane paralyzed the metropolis for days. Still, New Yorkers didn't learn their lesson.
We decided to build these big buildings and then use, gas and coal-powered fuel to heat the buildings, right? Which is leading to climate change, right? It's putting carbon dioxide in the atmosphere, which is leading to climate change, which is making the sea level rise, which is then flooding parts of the city. So there's no doubt if you were to start again, you would build the city in a different way, in a way that would be more compatible with the nature of the place.
In 400 years, Manhattan, which started out as virgin territory, morphed into an urban giant. 97% of its ground is covered in concrete. Today, this urbanization has become problematic.
The soil is like a huge sponge that can absorb the rainwater and the snow melt. But now you've like limited it. And so you actually make more floods happen because of that, right? It becomes flashier because the rain falls down and it has nowhere to go, right? It can't go down into the ground anymore. It can't go up into the vegetation because you've cleared all the trees. It can't go back into the atmosphere. So all it can do is flood. And that's why, just small rains, you get floods all over New York.
Luckily, New York had natural barriers that offered protection from storms. Except that, as it developed, almost every single one of them was destroyed. John F. Kennedy International Airport, 49 million passengers transit through here each year. JFK is located in the southeast of the city on Jamaica Bay. The bay stretches 100 square kilometers and is separated from the ocean by the Rockaway Peninsula. Originally, it was one of the East Coast's most beautiful nature reserves, an expanse of water strewn with a dozen marshy islets.
It's a paradise within the city. So when you go there, it's often hard to believe that you are still in New York City.
And yet this is where, in the late 40s, the airport runways were built right on top of the marshes which served to reduce wave energy.
Essentially, it became a place that was, over the years, it had been a dumping ground, and then it gradually became integrated into the rest of the city, but it had the issues of what had once been a wasteland. Of course, flat wetlands are often considered prime sites for creating airports, which need vast expanses of flat territory.
To dry out the marshlands, dredgers suck sand up from the bottom of the bay through huge pipes. The sand is then mixed with cement and dumped into the marshlands to make the ground more solid. The result? The vast majority of marshland in the bay has been paved over. To top it off, 4 water treatment plants have also been built here. They too contribute to polluting the bay and destroying the marshlands. And yet the marshes would have been a great help when Superstorm Sandy slammed the region with its gigantic waves.
Jamaica Bay, I think, because so much of its edges had been hardened, drained, developed, everything became basically paved over in a massive way. I think that definitely, things would have been different had it been a quite absorptive marsh platform.
Because marshlands act like barriers during storms. When waves come in from the ocean, wetlands act like sponges that absorb water and store it. This not only slows waves down, it also makes them smaller. But it's not just the marshlands in Jamaica Bay that have been destroyed. In reality, over 80% of the marshes throughout the entire city have been filled in. This is the case with Central Park, for example, New York's famous green lung. Here too, the wetlands were massively drained to build a vast artificial park. So how can the city make up for the absence of natural barriers? What if a tiny creature, just a few centimeters long, could save the city? A small shellfish that's become the new hero in the world war against climate change. In the southwest of the city is Staten Island, one of New York's 5 boroughs. The island was ravaged by Hurricane Sandy. 24 people lost their lives to the waves. But here, it's impossible to build a wall.
In Staten Island, you're dealing with a very, very residential fabric. And building a wall with such a low density wouldn't make sense, both from a risk reduction standpoint, from an economic standpoint.
And so another amazing project, which also won the city's design competition, consists of establishing oyster beds in the bay. These small shellfish can reduce wave energy. Actually, it's a little-known fact, but until the 19th century, New York was the oyster capital of the world.
New York City had an immense natural oyster production. Today we talk about New York as the Big Apple. But at the turn of the 19th century, we could easily have called it the Big Oyster. That's how characteristic oysters were to the economy here.
You know, in New York, you have like hot dog and food carts, so you can get a hot dog on every street corner. Back then, it used to be oyster carts. So people will stop walking in the street to buy oysters and have oysters on the street.
But today, with pollution and overfishing, oysters have disappeared from New York Bay. And yet, the shellfish played a primordial role, particularly in Staten Island.
You know that there was a place on the South Shore of Staten Island, there was an oyster reef, and you can see in the geologic record that that used to protect the shore. And then once that reef got reduced because of overfishing, then the shore became more vulnerable to overwash events and storm surge.
Why not look to the past for inspiration and recreate these famous oyster reefs? The problem is, the water in the bay is still polluted. There's no way oysters could grow on their own. They need help. These huge artificial breakwaters, built about 3 meters high out of stone, will be coated in a special ecological concrete and planted with oysters, which in time will colonize the entire structure.
Oysters come together in oyster reefs. It looks like coral reefs, basically. So they come together, they build those natural reefs. When one oyster dies, there is another one coming on top of it, and so those reefs keep building up.
The 9 breakwaters, 300 meters off the coast and stretching over a kilometer, will eventually function like this. As powerful waves crash over the top of the breakwaters, the structure's porosity will absorb the water and lessen the wave's energy. Coastal damage is therefore reduced.
The oyster projects are as much to do with the healthy ecology of the region as with storm protection. So I think that it's true that any kind of planting or wetlands or islands or oyster reefs, all of that contributes to the reduction of the storm energy before it hits the coast. But in the long haul, the oysters are also really good as a symbol of the health of the estuary.
Because these tiny mollusks have an amazing property. Each day, a single oyster can filter 200 liters of water all by itself. The water in these 2 containers is very dirty. Oysters have been placed in the one on the right. The result is astounding. After just a few hours, the water is nearly transparent. New York Bay could soon be cleaned in the same way.
It's a snowball effect, and the more oysters you put, the better the water quality gets, and the more oysters will be able to survive in the future.
The first breakwaters are scheduled for late 2018. But beware of food poisoning. New York's fin de claire won't be fit to appear on the menu until 2050. It's an ambitious project, no doubt, but is it enough to save the city? Because New York thought it was indestructible and has been quite reckless over the centuries. For instance, the city has actually expanded right into the water. And in storms, the people living in these zones are obviously the first to be affected. The figure is astonishing. In 400 years, Manhattan has grown 20% larger. When colonists arrived, it was 47 square meters. At the turn of the 19th century, the city began to spill over onto the rivers surrounding it. A century and a half later, the encroachment continued. Today, Manhattan boasts 12 square kilometers of additional land.
And in part, that was for real estate purposes. You know, people wanted more land. It's amazing for the Dutch and the early British. They actually found it more economical to build out than to build north, right? Because before cars, you had to walk everywhere you went, so you want to live close to everything, right? So they made this really compact city, and so they would fill out. And then later on in time, people needed space for industrial uses, they needed space for transportation, they needed space for housing.
Here's how the new land was created, and the island was able to expand over time.
So most of these new lands built around the edge are built with landfill that sometimes is from the demolition of hills in other parts of the city. So if somebody was removing rock to create the Empire State Building, that had to go someplace. So there would be some clever person who would think, aha, I'll buy this from you, I'm gonna put it over here in the water. You dump in soil, and voila, you have new land. And you've also solved somebody else's problem who didn't know what to do with the rock that they were cutting out.
The most striking example in this quid pro quo is Battery Park City, an extension built entirely from scratch around 1980 on the Hudson River. 37 hectares, 16 skyscrapers, a community of businesses and luxury housing.
Battery Park City is the most dramatic change recently in terms of the shoreline of New York.
To understand this amazing engineering feat, we need to go back to the 60s. The World Trade Center was under construction and tons of rock was being excavated. Builders chose the cheapest way to get rid of it, simply toss it into the Hudson. The rubble created a landfill site in the water. A few years later, the additional surface would provide a foundation for the construction of Battery Park City. Of course, this new land is the most susceptible to the effects of climate change, and here's why. In color, the areas added to Manhattan over time. And in red, the priority evacuation zones in case of storm. They correspond exactly to where the river was 4 centuries ago. During a hurricane, water simply returns to its original place.
We thought that those places were fine to live in, and we now see that, in fact, with a combination of things, that climate-driven sea level rise, as well as more increased and stronger storms, those places are actually at risk.
And yet, even if the risks have been well known for 30-odd years, building on the waterfront continues. Are New Yorkers playing Russian roulette?
Yeah, the Russian roulette comes into play once we knew that sea level rise is going to happen. And that was foolish and short-sighted because theoretically the knowledge was already available. And that still applies today. We are still putting new buildings and assets on the waterfront instead of thinking 50, 100, 200 years ahead in terms of where we place our future assets.
At 11,000 euros per square meter on the waterfront, the temptation to continue building in these zones is tremendous. What if the answer were to build totally waterproof skyscrapers? Overlooking the East River, behold the American Copper Building. It has just been completed and is New York's first waterproof building. The building stands right in the flood zone, and for good reason.
If you were to take a map of Manhattan in about the 1920s or 1930s, and you put this building on that map, you would see that this building is sitting in the river. And we knew that this lot sat on landfill when we bought it. So we knew that the soil underneath this lot was not going to support a foundation.
The building is supported by enormous pillars sunk into the bedrock 90 meters down. Inside, a classic luxury skyscraper. A gym with breathtaking view, upscale apartments, and gaming room overlooking the river. Purchased post-Sandy, the building was designed so that residents could survive as long as possible without electricity. Because during Sandy, the electrical equipment and countless skyscrapers in Lower Manhattan got flooded.
The biggest lasting impact was people living without electricity. So no elevators, no flushing toilets, no water being pumped up to the 20th, 30th, 50th floor, no lights on these higher floors. So we asked ourselves the question immediately after the hurricane, will people still want to live on the waterfront? Is it still safe to live here? The answer is, of course, yes.
But how to ensure that this skyscraper built on the water does not flood? First, an ultra-sophisticated drainage system was created around the foundations of the two towers. During storms, the water is collected and channeled through a network of underground pipes to huge reservoirs that can hold over 100,000 liters of water. Once water levels have dropped back to normal, the reservoirs are emptied into the East River. But the technique may not be enough. So a backup sump system has been installed in the basement to make the building truly waterproof.
Most buildings don't have a whole sump system in the basement, let alone 10 or 12 of these sump systems to be able to deal with a whole volume of water in the basement. So these pumps can deal with that, and we have a primary pump and a secondary pump in every single location to make sure that there's always a backup in the event that one pump fails.
In the event of a general power outage, the builders have thought of everything. But to do so, they had to sacrifice the best apartment, the one that would have gone for the highest price.
Level 48.
Here we are on the top floor, where, in theory, the grand luxury suite is located. But instead, it's the home of 5 powerful backup generators, able to furnish 2 megawatts of electricity, enough to power the entire skyscraper for a week in the event of a storm.
In the event that happens, we have refrigerators in everyone's apartments, charging outlets in everyone's apartments, all the elevators, the domestic water pumps, the gas pumps, basic heat, all of those things are covered on this system.
A system that, in theory, will protect the people living in this building. But what about all the other New Yorkers? How can the public network also be waterproofed? Given the risks, the city has made the first move. New infrastructures have already been built, notably to protect the transportation network. Because Hurricane Sandy dealt a huge blow to the city's subway and tunnels. Thousands of cubic meters of salt water gushed into the corridors. The subway shut down for 7 days.
The subway system has all the entrances into the subway, some of which are in low parts of the city, and so that was a place where the water could get in through the entrances into the stations and from the stations into the tunnels. So many of the stations were flooded, many of the tunnels were flooded, and that damaged a lot of the electrical systems and the signal systems.
The subways weren't working, so everybody tried to drive their car into Manhattan, so there was just, all across the city, there was this massive traffic jam and nobody could get anywhere.
A nightmare for New Yorkers, since 5.5 million people take the subway each day.
That is the Achilles heel of New York City. When the subway goes down, the city goes down.
So how to protect the subway from floods? How to prevent water from entering the 3,600 entrances at risk? A dozen high-tech solutions have been invented. Already, subway entrances can be covered with these sheets of waterproof fabric. Custom-tailored and spooled in a container perpendicular to the entrance steps, the sheets can be unfurled in just 5 to 10 minutes to cover the entire staircase opening. They've been installed mainly in Lower Manhattan. The elevators are protected by watertight steel bars that are manually put in place. Inside the subway itself, massive hermetic custom-built doors, like submarine hatches, will be able to keep water out.
It's a part of a toolbox of different tools to keep the subway system running for maybe another 50 or maybe to the end of the century.
And the final weak link, the road tunnels that run between New York's boroughs. When they're flooded, the entire city is paralyzed.
New York's tunnels, by definition, are below ground level, and some of them are below sea level, underneath the bay. The tunnel between Manhattan and Brooklyn, and the tunnel between Manhattan and New Jersey on the other side, those were built a long time ago, so they're not watertight.
Here's the solution. Monumental steel doors weighing 25 tons, measuring 9 meters long and 4 meters tall. 8 of them are already in place. They've been designed to withstand a rise in sea level 1.2 meters higher than Sandy's waves. But in light of the extreme violence of storms, they may not be enough.
If you cover up all the entrances, you still can't be sure that every of those entrances will work 100%. So you still want to impede the flow in the tunnels if something goes wrong at the surface.
Engineers have got a lot of imagination. They've devised a giant inflatable balloon. 10 meters long and 5 meters in diameter, its volume is equal to 132 cubic meters, the equivalent of a large residential pool. It can be inflated in just 30 minutes. Its material is ultra-resistant, similar to the kind used for spacesuits. Once it's completely inflated and pressurized, the balloon will fully plug the tunnel, preventing water from seeping in.
It's a bit like airbags in cars. An inflatable device that can blow up and contain the water. It's a brilliant idea because it doesn't require the creation of any heavy infrastructure.
Despite all these solutions on offer, it may already be too late. For many, it would be suicidal to continue living on the waterfront. If the sea level were to rise by 2 meters, Manhattan would be underwater. What if the only true solution was to simply leave the island? Greenwood Cemetery in Brooklyn in southeastern New York. 600,000 graves on a plot of 2 square kilometers. Altitude 67 meters above sea level.
They have wonderful vistas over the whole harbor. But it's low-density living of the dead.
Could this be the solution? Leave the waterfront and move to the heights of the city. New York is fortunate to possess several areas that are high up. It's just that many of them are cemeteries, like here in Brooklyn, in the Bronx, and in Queens.
So we would have to switch to living in the dead, or they are neighborhoods that are relatively low density. So you would have to develop a new zoning for those areas so you can allow new high-rise buildings to be erected there.
The idea sounds crazy, but given the extremely serious risks, experts are convinced it's the only way people will be able to continue living in New York.
Yeah, many people think I'm crazy, but that doesn't bother me because I think they are crazy if they want to build on the waterfront. So we will have a few more Sandys, and more people will come to appreciate that a forward-looking view with a little bit of foresight will be actually more good than just craziness.
For 400 years, New York has been developing in an increasingly grandiose, increasingly over-the-top way, completely ignoring the fact it was surrounded by water. Today, the element that created it could very well be its downfall. So the world's giant no longer has a choice: drown or reinvent itself. The answers, each one more ingenious than the last, will have to surpass the countless economic interests. That is the cost at which New York will be saved.